In this video, we're going to be learning about arithmetic series. And before I get into what an arithmetic series is, let's just first talk about what a series is by itself. Because we've been saying arithmetic sequences, not series. So a sequence is just a list of numbers. A series is the sum of a list of numbers. So if you were to add all the numbers together, what would you get? And that's what we're talking about with a series. Some series have patterns like we've been learning, like arithmetic and geometric. And some series have no pattern as well. Some series are finite or infinite. And an infinite series might sound a little strange to you. What an infinite series is like if I took, let's say, a pattern of numbers like 100 plus 50 plus 25 plus 12.5. You can tell that these numbers are being divided by 2, so that's a geometric pattern. But what if I told you to add some of these numbers in the list forever and ever and ever and ever, like keep adding them forever? You might be thinking, Ms. Trahan, that's crazy. They'll never add up to some number, but they actually, in some situations, do, and we're going to talk more about that later. All right, next is this crazy looking symbol. I know it looks really scary to you guys. It's called sigma, is what it's called. It's a Greek letter, sigma. But in math, this symbol means to sum. It means to add up a list of numbers. So here's an example of a problem with a sigma in it. And you just gotta kind of need to learn what all these positions mean. So this guy down here is the position of the first term in the sum. This guy up on top is the position of the last term in the sum. And this thing in here is like an explicit formula. That's what it is. It's a formula that tells you how to calculate the numbers in the list. So the way you would find this sum is first generate the list of numbers. So we're going to start with the second term because that's what it says here, and then the third, and then the fifth, and we're going to stop. And these are position numbers, okay? We're going to start when n is 2 and stop when n is 5. So when n is 2, we would plug 2 in. The term would be 2 squared minus 1. That's 4 minus 1, which is 3. And when n is 3, plug that in. 3 squared minus 1, 9 minus 1 is 8. And when n is 4, 16 minus 1 is 15, and when n is 5, 25 minus 1 is 24. And the sigma means you add those up. So the last thing you do is add those numbers, and I'll just go to my calculator and get 3 plus 8 plus 15 plus 24, and the answer to this problem is 50. Okay? So I'm going to do 2 of these with you, and then you're going to do 2 on your own. So I'll do numbers 1 and 2. You'll do 3 and 4. So what this is telling me is to find the sum of all the terms from 2 to 5 and the terms I get from plugging n in. So the second term, or plug 2 in, I'll get 10 over 2. And then I'll get 10 over 3 and 10 over 4. And I'll stop at 10 over 5. And then I just add those up. And of course I could have written this as 5 instead of 10 over 2, same thing. But I'll just leave it and type all these in with parentheses in my calculator. .83 repeating, which I'm sure I could make into a fraction if I wanted to. 77 over 6. Either answer is acceptable. Okay, and the second one, we start when n is 2 and we continue till n is 8. And this is an easy formula to plug into. So when n is 2, you just get 2. And when n is 3, you just get 3 and 4 and 5 and 6 and 7 and 8. And we stop when n is 8, which is clearly an arithmetic pattern. We're just adding by 1 each time. But add those up 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8, and I get 35. All right, your turn. Do the last two videos, problems.